In this particular workshop, you talk a lot about the AI and possibly AI in a healthcare. Okay. So this is the another way to represent that AI in a healthcare, that is a smart healthcare. Okay. So I will be introducing what do you mean by smart healthcare, how you can adapt it, what you expect from a smart healthcare. Then I will talk about the variable technology, which is one of the very important aspect of the smart healthcare. Then I will discuss about some of the case study where currently I am working on. Then I will discuss about some of the emerging application, and finally I will conclude with the some of the challenges. Now, what is smart healthcare? Okay, before going to smart healthcare, first let's understand what is the traditional health. Okay, so in a traditional healthcare system, when a particular person, let's say, is admitted in a ICU, and you require one dedicated medical staff to take care of that particular person 24/7. Okay, and that is actually we mean by intensive care unit, where we view all the parameter of that particular patient, and that particular dedicated staff is assigned who is looking for that particular parameter. Sometimes the absence of that particular supporting staff may lead to a loss of life of a patient. Okay, apart from that, when we talk about our traditional healthcare system, that it is somewhat decentralized. What I mean by decentralized, that there are multiple stakeholders are there, but they are playing their individual role, but they are not talking with each other. Okay, what I mean to say that it is something like that. If I am not feeling well, I just visit the doctor, and doctor will ask me to go to a laboratory where I provide my sample. Then I will collect the report from a laboratory. Then from that report, I will go to the doctor again. Now doctor will give some sort of prescription of the medicine. I will go to purchase that medicine at the medical shop, and then possibly my treatment start. Okay. Now consider a case that a person is in a not well condition or in a some critical condition. Then possibly this is somewhat a tedious job he has to follow. And to be honest, that when you are not feeling well, then everything should be available at your doorstep. Okay. And most of the time, if you just consider this particular scenario, then as a patient, I am just considered as a carrier where I am just passing the information from a doctor to the possibly pathology lab, from the pathology lab to a doctor, and from a doctor to a medical shop. So over here, what we want that they should be connected with each other. So all should share the information among themselves. Okay. And I should get the final result regarding the medication or some sort of preventive mechanism. Okay. Now, what is the role of IOMT? Now, IOMT will play a very important role. Okay. So whenever I use the IoT technology in a healthcare domain, then I term them it is an Internet of Medical Things. Okay. So that is a IOMT. So IOMT, where you have so many medical devices are being connected with each other, and they actually exchange some important information. Okay. Through IOMT, I can basically consider to have a remote patient diagnosis. I can think about the treatment. I can have some sort of initial early screening or monitoring. So ultimately, the role of adopting the IOMT in our healthcare domain is to have some sort of value-added, affordable, and accessible service where I can access the real-time healthcare data. Okay. Now, why smart healthcare is important? Okay. So in a smart healthcare, what we are actually looking for, that there is a sensor which I consider as a things, which is basically a basic element of your IoT. So sensor will collect the data. The data is being generated from a people, and whatever the data which is generated from a people, where I will apply some sort of intelligence algorithm like AI ML techniques I apply to those particular data, and then I will try to derive some decision out of it. Okay, that decision could be related to the disease prevention or it could be related to the early diagnosis. But ultimate goal is by adopting a smart healthcare is ultimately I am looking for a continuous health monitoring. I am required some sort of healthcare automation. I require drug delivery management, and I require a preventive healthcare mechanism. So when I talk about a smart healthcare, then smart healthcare is not only deal with the diagnosis of the problem. Okay. So ultimately, in a smart healthcare, we are looking for having a closed loop solution. But after diagnosing the problem, you are also providing some sort of automation in order to get some sort of preventive action or in order to get some treatment as well. Okay, so that is a closed loop solution. So that only the diagnosis is not only a scenario. Ultimately, you are providing some primary healthcare mechanism also to cater that particular disease. Now, what are the benefits? Okay, so benefits is basically by having a IoT in your healthcare will allow us to have a improved in diagnosis and a treatment. Okay, it will allow us to have a improved disease management mechanism. It will allow to decrease the cost. Definitely means it will be easier to understand the healthcare mechanism or body structure of our body, and possibly we will take the accordingly the remedial solution for that. It will also enhance the patent solution. So ultimately, remotely, you can monitor the parameter of some of the people. Okay, it will help us to improve drug management mechanism, which is very important. After diagnosis, I want to cure that particular disease. Okay, so for that, maybe I can have some sort of drug delivery mechanism, and remote monitoring of the chronic illness is possible. Now, when I talk about the IOMT structure, that IOMT is basically divided into the 4 layer. Okay, so it starts with the data collection layer. When I say data collection, then data is being collected by a sensor. Okay, so whatever the sensor that you attach to your body, from that whatever the data which is being generated, the data is being generated that you transmit through a network. Okay, so either through a Zigbee module, Bluetooth, or maybe Wi-Fi, whatever. It could be a wireless or wired. Through that particular network connection, we are supplying the data to a cloud. So now at the cloud, the data is being stored. Now that data is further processed, and then we are deriving some decision. According to that decision, we are applying to a one particular application. Okay, so that is overall IOMT system architecture. Okay, now in IOMT, what are the purpose of the different layer? So I have already talked about, but let's try to understand it. That what is the role? Okay, so collection layer is the main layer. Okay, through which you are collecting or sensing or capturing the data.
Excuse me, sir.
Huh?
Sorry for interruption, sir. Actually, your slides, I think either you have not shared or like.
Okay, is it so?
Yeah.
Sorry. Thank you for letting me know.
Yes, sir. So actually, so it was the introduction kind, so I didn't disturb you. Either I was thinking that either.
No. Sorry.
Sir.
Okay. Ultimately, we were talking about the. I think now it is visible.
Yes, sir. Yes, sir. Now it's visible, sir.
Okay. So basically, we talk about the traditional healthcare. Do we talk about the IOMT? Okay. Now, basically, in a smart healthcare, this is the diagram where actually I talk about that the data is being collected from a sensor, then it will be processed, and then it will be useful for the particular application. These are the benefits that we discuss. These are the 4 different layers of the IOMT that we just discussed about. Okay. Ultimately, there is a data collection layer. So what is the role of the data collection layer? Data collection layer is basically responsible to retrieving the information. Okay, from the patient. So it could be through a sensor or it should be some another way. You are getting patient data in transaction layer. So that is the data which is being collected that you are transmitting to the cloud. Data management layer. Data management layer is a layer which have a connectivity, which provides the connectivity of the all medical devices. So that is, it could be a case that in order to take a decision for a particular disease, you require a multiple sensor data. So data fusion is also has to be done. Then data storage has to be done. Data processing has to be done. Okay. So all these things could be done at the data management layer. Application layer is basically a endpoint where you try to control the thing. So it is something like that. If I have diagnosis something, then possibly I want to provide some sort of remedial solution. Okay, so that is basically a role of the application layer. Now, medical internet of things. Okay, so whenever I use the IoT in a medical, then we used to term them is a medical internet of things, or sometimes it is being used as an internet of medical things. Now, over here, we collect the data from a patient. So that is a different kind of physiological parameter or some sort of important parameter of your body that you analyze it, that you transmit it, and then you take some sort of decision. Now, such kind of technology will play a very important role for tracking and preventing the chronic illness. Okay. Now, what do you mean by chronic illness? Chronic illness are one category of the illness which gradually develop inside the body. Okay. They don't have any visible symptoms like diabetes. Okay. So for a diabetes, you don't have a fever, or maybe there is no such kind of headache, nausea. Okay. So these symptoms are not visible, but still your body is having a high blood glucose value, which remains unnoticed. Similarly, hypertension. But a hypertension, your blood pressure is shooting up, but you are unable to actually identify that particular scenario. So here, this is the scenario where we need to take care of. So now, what are the different kind of IOMT device? IOMT device can be categorized as a variable device, implantable device, or maybe some sort of supportive mechanism for a device. Now, variable devices. Variable devices are a device which can help us to monitor and manage the chronic illness. Okay. So, like diabetes or hypertension. So, that basically a chronic illness for which you require a continuous data collection. Okay. So, variable technology will be helpful to that. We will separately discuss about the variable technology in details. Okay. So, I'm not talking about this at this particular moment, but definitely we will be discussing. Another is an implantable device. Okay. Now, implantable device are those devices which you implant within the human body. Okay. So, means where you will inject something inside the body. So, that is some sort of invasive in nature. But when we talk about the variable, then they are non-invasive nature. So, now what I mean by non-invasive means you just play around your body surface. From the body surface only, you are trying to measure or capture the important parameter. But when we talk about the implantable device, then in the implantable device, you will implant inside the body and through which you are taking some measurement. So here, basically the examples are the pacemaker, your insulin pump, your cochlear implant. So that is related to your hearing problem. So all are implantable device. Okay. Now, what are some of the implantable device that we have? Pacemaker, implantable cardiac monitor, glucose monitor, and these are is the pacemaker. Okay, what is the role of the pacemaker? Possibly we heard this particular word. Okay, so basically, heart is responsible for circulating of the blood, and heart you consider is one of the very important organ of your body. Okay, so heart will do the pumping. Okay, so ideally we consider that for a healthy person in a rest position, the pumping of the heart or beating of the heart is around 75 times in a minute. Okay, so that we used to term that beats per minute. So 75 beats per minute is a conventional way of identifying the healthy body structure. Okay, now if there is a irregular heartbeat, that means if that heartbeat is varying maybe greater than 100 or below 50-60, then possibly we consider that it is a arrhythmia. Okay, so when there is a arrhythmia problem, then you need to consider the pacemaker. Okay, so pacemaker will provide you the proper electrical impulse inside your heart, so your heart pumping now in a proper with the proper frequency. Okay, so that is the role of the pacemaker. Now, implantable device. So implantable cardiac monitor is also very fast growing market. Okay, because we possibly means observed that the heart related problem is popping day by day, increasingly, and possibly the heart attack is one of the prominent cause through which the death of the people is occurring. Now, insulin pump. So insulin pump is also very important to actually manage your blood glucose value. So we will discuss in a case study in the diabetes that what is this role. Okay. Now, cochlear implant. So that is basically related to the problem in the hearing sensory. Okay. So for that, you can use the such kind of implantable device. Now, another important term which we need to understand is a healthcare cyber physical system. Okay. Now, usually cyber physical system you can term is a system where you have some sort of hardware and software through which you are trying to solve some health related problem to have some sort of value added service Okay. So now, whenever I use the concept of the CPS in a healthcare domain, then I used to term them in a healthcare cyber physical system or medical cyber physical system. Okay. Now, what are the different features? Okay. So, the what way I can consider that I am adopting a smart healthcare? Okay. So, with the smart healthcare, you can connect with a doctor with a remote location. Okay. So, that is the concept of telemedicine. Okay. So, in a telemedicine concept, the patient can consult a doctor from a remote location, and doctor can also allow to provide the teleconsultancy service to a patient. So this could be possible with the help of the smart healthcare. Okay, so where they can connect like a the way we are connecting. Okay, so I am sitting at MNIT Jaipur, and maybe the participants are residing at a different part of the India. Still we are connected with each other through some sort of internet connectivity. So similar way, the telemedicine concept is do exist in a current scenario, and where doctor are actually preferred to meet with the patient. Okay, then continuous monitoring of the critical condition you could be done. Okay, so as I said that dedicated supporting staff requirement is there. Okay, so that could be technology, where I can have a technology where sensors are being placed and all the data is being captured, and that is being logged into the cloud. Okay, and automatically there will be some mechanism that if some parameter is having some sort of deviation than its standard value, then possibly it could send the warning signal to a healthcare professional or maybe to a caretaker. Okay, with this, you can take some corrective action and the quality of the care for the proper diagnosis. Okay, so diagnosis of the disease at the original is a very important. So that we consider as an early diagnosis. As early as we identify the root cause of the disease, then the more and more chances that we can get the come back to a healthy state in fewer days. Okay, so corrective action could be also possible according to whatever the disease is available inside our body. Real-time access of the data, so that is very important. Okay, with such kind of technology, what you can do that you can actually real-timely accessing the data of a patient. So it is something like that if my parents are not well and they are sitting at my home, then from my office place also I can monitor the health condition of my parents. Okay, so it is something like a virtually I am present in front of them and I am monitoring their health status. Apart from that, point of care service and medication could be possible with the some sort of intelligent consumer electronics device. Now, what are the different attributes that we can expect from the smart healthcare? Okay, so one thing that I expected, the whatever the component that is available in a smart healthcare, that should be always on. So it is something like that when I'm sleeping, but still my body is working. So at that time also, I want to capture the important parameter of my body. So it should be always on. They should be always connected. So that means whatever the data which is being captured by a sensor, they should be stored at the cloud. So it is something like that during my busy time or while I am sleeping, whatever the data which is being captured, that I can view at the later on. Quality of the content is also very much important. So whatever the sensor that we adopt and what are the things that we have adopt in a IoMT network, those should be capable enough to capture the data with a good quality. Location hands-free, it should have a good sensing capability. It should be environment aware. We should also consider the development platform. So that means how good we can approach or we can adapt that particular solution. Okay, so ultimately most of the time I used to attach those sensor onto my body. Okay, so at that time they should be user friendly in nature. Okay, and they should be a cost effective solution as well. And apart from that, most important thing is it should be a multifunction. So it is something like that I want to capture as many parameter as I can do from my body, but at the same time I do not want to wear that many number of sensor on my body. Okay, so for that, what could be the scenario that I could choose a sensor which could be a multifunction. So that means one particular sensor can actually capture the multiple parameter of the body. So that is what I am requiring in a smart healthcare. Now what are the different components of the smart health? Okay, so let's try to discuss it. E-health. E-health is the one of the very important component of the smart healthcare where I use the ICT technology. Okay, so if I use the internet or maybe I use some sort of information communication technology tool to communicate, then ultimately it is a e-health component. Okay, so telemedicine is a practice, okay, where the doctors and the patient is basically connected with each other through e-health component. Now m-health. M-health is also one of the very important component when I use a mobile phone. Okay, now we consider the mobile phone is a one of the very important integral part of a particular person. Okay, so we can reach out to individual very easily with the help of the mobile phone. So now m-health is a component where you take out a data with the help of the mobile phone or mobile application. Okay, so it will help us to provide a healthcare related information to a practitioner, maybe a doctor professionals, or maybe a researcher, or of a patient through some sort of convenient way of maybe through some sort of message through a WhatsApp or some sort of SMS services. Okay, so one of the first application which is being developed under the m-health category is your m-hero. M-hero is an application which is being developed by a UNICEF during the crisis of Ebola. Okay, that crisis occurs during the 2014 in a African region. So over there, UNICEF wants to send the message to the public over there for the awareness. Okay, for the vigilance purpose. So they use this particular app, and through it they used to circulate the messages over the people there. Similar way, one of the application which is uh, under the category of the mHealth, which we have used it during the COVID period. Okay, maybe all of you are recalling also that Arogya Setu. So Arogya Setu is one of the very good application which was popular during the COVID period. Okay, where through Arogya Setu we used to book our vaccination. We used to download our vaccination certificate. Even that application allow us to identify that how many COVID infected patient is surrounding within a 1 kilometer region or maybe 3 kilometer region. So that is a Arogya Setu, which we consider as a mHealth application. Okay, so with mHealth, the real-time monitoring of the patient vital sign and direct provision of the care is possible very easily. Now, with the mHealth, you can have a rapid collection and sharing of the current information. So that is possible. Okay, so it is something like that means whatever the report which is being generated or whatever the test result which is being supplied by a means your laboratory, so that usually they will provide it through a WhatsApp. Okay, so that you can easily share with the doctors or maybe your caretaker. Okay, so that is possible with the mHealth application. The public health and lifestyle messages can be sent easily through a mobile phone. Medication alert can be sent through the mobile phone. E-prescription. So basically, e-prescription or you get tele-prescription. Both could be considered to be same. Okay, where doctor will prescribe you the medicine. Okay, or provide the consultancy service through an online mode. Then we consider that mobile phone can be also useful at that particular time. Telemonitoring. Okay, that is also possible with the mHealth application. So transmission of a test result to a patient could be also done easily with the mHealth application. Now, another important component of a healthcare is a connected health. So in the first slide itself, we talk about that there is a decentralized system. Okay, so there are multiple stakeholders in a healthcare domain where doctors are there, your medical shop people is there, your laboratory peoples are there. So they are playing their individual role, but they are not exchanging the information among themselves. Okay, but in a connected health, what we want that all are being connected with each other. They share the common information to each other, and the exchange of the information will be taken care automatically among themselves. Okay, so as a patient I don't have to play any role that we used to play in a traditional healthcare. Okay, so if doctor has given some prescription, then I can directly visit to a medical shop and then the medicine is ready for me. Okay, so this could be possible. Okay, so what we can do it that over here all the data which is related to medical can be stored over here. So that is basically we consider EHR, electronics health record. Okay, so that electronics health record is being stored at the cloud against each individual ID. Okay, so currently in our India also that government has launched a Aadhaar card. Okay, I hope that many of you have heard it. Okay, so what do you mean by Aadhaar card? Aadhaar card is basically providing one ID. Against that ID, all the information regarding the patient is being stored over there. Okay, so it is something like that doctor has given some prescription, then against that ABA ID, the medical shop person can easily retrieve and means he can just allow me to purchase those medicine. Similarly, if a particular test is being performed and test report is being generated against that ABA ID, so the doctor can easily view with the ABA ID. The biggest gainer of the connected health network is the insurance. Okay, so in current scenario, the insurance claim is a very tedious job in our country. Okay, so what is the scenario that if I am going to admit or I am admitting in a particular hospital, then I need to inform the insurance agent about the same. Okay, so if I am going for a surgery, then at that time also I need to inform the uh, our insurance agent. Now, what is the role of that insurance agent? The insurance agent will visit the hospital or one of the representative will visit the hospital and then the claim is being passed. Now, this could be a seamless where all the information against the digital ID of a patient. So insurance company can easily verify those details and your insurance can be passed within no time. So sooner or later, this will be the system will be placed in our country as well. So consumer electronics. Okay, so there are various consumer electronics devices are available. Okay, which is in terms of the smart belt. It could be in terms of the smart watch, smart ring, smart earphone, fitness tracker, smart clothes. So all are available. Okay, so all will be available, which actually help us to capture the important parameter of your body. Now we will talk about the variable technology. So what is the variable technology? Variable technology is a technology where you worn by a people on the body and it could be either as a cloth or some sort of accessory. Okay, so that we consider as a variable technology. Now it actually help us to track the health regularly. Okay, so you can buy your own only, you can monitor your vital parameter, okay, and observe the changes. Then it also allow us to have reduce the hospital visit. Okay, so that is very important. Okay, so it will help us to identify that when I need to consult a doctor. Okay, because we are very busy in right now with our daily activity. Okay, so we hardly find any time to take or look for ourselves. But through the variable technology, the parameter is being captured and that is being stored at the cloud. Okay, so that I can observe it. And if any deviation or any critical reading is observed in those parameters, then I can decide that whether I need to consult a doctor or I need to visit the hospital. Another is a readmission. So readmission is a scenario where a particular patient is being admitted in a hospital within some specific duration for a same disease. Okay, so it is very important that I should not be visit a hospital or I should not be admitted in a hospital for a same disease within certain duration. Okay, because many times you observe that few diseases are a contagious. Okay, so that used to happen occur again and again inside our body. So for those diseases, if I need to visit the hospital or admit in a hospital within let's say few months, then that is also not good for me. It is a worrying part. Okay, apart from that, this create a more issue for the insurance company. Okay, because insurance company has to settle the claim amount for each and individual patient till it reaches to its maximum limit. So if you are claiming for a same disease or a different disease, it doesn't bother. But if your claim is, let's say, 5 lakh, then you are entitled to get the 5 lakh claim within a year. Okay. So that could be avoided with the proper understanding of when a particular patient has to be discharged. So for that also the variable technology plays a very crucial role. And such kind of technologies are more popular after the post-COVID era. Now, what is the trends of the variable technology? Okay, so variable technology are basically available in the market in a terms of the fitness tracker, smart watches. Okay, many of us actually using such kind of technology. That smart watches are very popular. Okay, virtual reality headset, your sleep tracker, smart clothing, smart eyewear, posture correction. So all these are the current trends which are available in a healthcare technology. Now, when I talk about the healthcare technology has a biggest market. Okay. So currently Apple, Google's, all the big giants are basically focusing in a variable technology because they see a huge potential in a near future in a variable technology. Okay, so possibly in a 2-3 years, you just observe that many people are basically habitual to use such kind of variable technology in their day-to-day life. So variable monitoring system. So for what purpose such kind of variable technology are useful? So they can be useful for the chronic illness. Okay, they can be useful for the preventive healthcare mechanism. They can be useful for the acute care, maybe for the some sort of emergency or hospital care. They can be useful. Now, what are the benefits of having a variable technology along with the IoT? That we term as a smart healthcare. So in a smart healthcare, IoT is also there, variable technology is also there. But when we combine this both the technology in a smart healthcare, then that will allow us to get the real-time health monitoring. Okay. Then alerts and alarm can be monitored. Okay, for a critical parameter for a some sort of specific kind of patient. Then patient physics and information sharing is easily possible in this particular technology based solution. And social media sharing, that is very popular. Okay, that I just capture the information and then I share it and share it in a social media. So what are the basically pros and cons of such kind of variable technology? Okay, so such kind of variable technology can help us to monitor the fitness level, track our location with the GPS. It allows us to have a portability and a hands-free solution. So it is something like that. I am doing my daily activity. Along with that, this technology allows me to take care of the important parameters. Okay. It is always connected to a smart device. So the data is being captured and it is being stored at the cloud. So whenever it is required, I can view it in a later on. It can allow us to set the goals and track your progress. Okay. So these all are a, you can consider the advantage. What are the disadvantage? Disadvantage that it could have a shorter battery life. It measures the data inaccurately. Okay. So that is the biggest worry, that whatever the data that you are capturing, that should be accurate enough. We are talking about the healthcare domain. So in a healthcare domain, we are dealing the life of the people. So at that time, accuracy is the very much important. But such kind of variable device which are available in the market, they are not generating a accurate data. Okay, now we will start with the case study. So I will mainly discuss about the 3 case study. Okay, now till this point, if you have any question, I would be more than happy to answer those. Yes, any question?
If someone is having any question, they can put up it in chat box.
Okay, maybe I may not be able to visible the chat box. Maybe sir, you can read out and let me know if at all any query is there. Okay.
Okay, sir, I will convey any message.
Okay. Okay. So meanwhile, let's talk about the case study. Okay. So the first case study that we are going to discuss for the smart healthcare mechanism is a diabetes measurement and control. Now, when I consider the diabetes, then diabetes is a crisis for this particular century. Okay. So currently around 480 million people around the world suffering from diabetes. And if you are a diabetic patient, the first thing that you need to do is you need to measure your body blood glucose frequently in a day. Ideally, 3 to 4 times in a day, you need to measure the body blood glucose value. The reason is the body blood glucose value keep on changing throughout the day. It is something like that. When I start this lecture at 2 o'clock, I have a one particular body blood glucose value. Could be at this particular point at 240 or 245. There is a different blood glucose value at my body. Okay. So ultimately, if I want to measure the body blood glucose value, then what are the available options? So currently, if I want to measure the glucose value, then there are two ways through which I can measure it. First is I can visit the laboratory. At the laboratory, I will give my blood sample. Okay, so they will take out the blood from my body. Then they collect in some sort of test tube. And then from that, they are measuring their body blood glucose value. Now, second is using the self-monitoring device. You can purchase the device from the market and then you can measure the body blood glucose value. Now, either of this way, you need to pinch inside the body. So that means it is invasive in nature. Okay. So it would be very difficult to adopt this daily 3 to 4 times in a day. Even at our age also, it is very difficult. But when we consider the diabetes actually comes with the age. So after 50 or after 60 age, it is very difficult to get a puncturing inside your body and take out the blood out of it. Okay. So for that, you require some sort of smart healthcare solution. Apart from that, once you are entering into a diabetic condition, you need to take care of your diet. So diet control is one of the very important, you can consider, aspect for the diabetes patient. Now, diabetes is a root cause of many diseases. Okay. So all the diseases are basically due to the diabetes. Alzheimer, your hearing problem, eye damage, cardiovascular disease, bladder problem, kidney, nerve, or foot damage, all are disease where the root cause is diabetes. Now, how the diabetes can be identified? So diabetes is a chronic illness. So there is no visible symptom. Okay. But there are some early symptoms which you can actually take care of that like a frequent urine excursion, like you find hungriness and thirstiness constantly inside your body. You have some sort of kidney related issue. You observe some sort of weight loss or tiredness, or there will be a vision changes. There is some sort of nerve system damage. So for all this, the diabetes is a prominent you can consider factor. So, but it is not necessary that these symptoms can lead to a diabetes. Okay. But if these symptoms are there, then there is a likely case that you are entering into the diabetic case. Okay. Now, once you enter into the diabetic case, then the probability of the death is increased 50% than the non-diabetic patient. Okay. If we talk about the India, then India is having a second largest population of the diabetic patient. Okay, first is China and second is India. So in India currently 85 to 90 million people are suffering from diabetes. Now, what are the different types of the diabetes? Okay, so there are three main category of the diabetes, okay, which we need to understand. Then first is a type 1 diabetes. Second is a type 2 diabetes. And third is a gestational diabetes. So let's talk about the last one. Gestational diabetes is a temporary diabetes condition which occurs during the pregnancy period of the woman. Okay. But once the pregnancy is over, this diabetes will disappear. The permanent category of the diabetes is either type 1 diabetes or type 2 diabetes. Okay. Now, when I say diabetes, then diabetes is a condition when you have a higher body blood glucose value. When your body is having a high body blood glucose value, then that we used to term as a hyperglycemia. Okay. But if you consider, then glucose is a very important component of our body. If you observe that at any point of time, if you are being admitted to a hospital and your diet is not proper, your doctor will suggest you to put on a glucose bottle. Okay. So glucose is a very important component. Inside the body, you should have some sort of basic level of the glucose quantity in order to perform your daily activity. If your glucose value is too low, which is lesser than 60 mg per dl, then possibly we consider as a hypoglycemia stage. So ideally, your body should have a glucose value in the range of 80 to 150. 140 above is considered to be a hyperglycemia, and your 60 below you can consider is your hypoglycemia. Now, glucose is very important, okay, because that is a source of energy to perform the daily activity. But excess amount of the glucose is a problem. Now, that is basically a diabetes. Now, when you take some food item, then inside your pancreas, the glucagon hormone is generated. Now, that glucagon is being neutralized with the insulin. So, if you have excess amount of the glucose, then the insulin is there inside the pancreas, which will be automatically generated, and then your glucose value can be in the balanced form. But if your body is not having an insulin or not having enough insulin generation capacity, then you have a type 1 and type 2 diabetes. Type 2 diabetes is a condition where your body is able to, or your pancreas is able to generate the insulin, but it is not adequate enough to neutralize the high glucose value. Or in a type 1 diabetes case, what happens that your pancreas is unable to generate any insulin. So no insulin generation inside the pancreas. So whenever you take a food item, then your body blood glucose will shoots up only. So at that particular moment, the insulin injection is being preferred choice. That insulin is injected inside the body. Okay. In a type 2 diabetes, sometimes people used to take the medicine in order to cure that diabetes condition. Now, continuous diabetes or continuous glucose monitoring. This is very much important. So ideally, you need to measure the 4 to 5 times of glucose value. Now, for that, whatever the current methodology that I need to pinch inside the body and take out the blood, that is not the convenient one. So we suggest a non-invasive solution. Non-invasive solution, that means over there, I can measure the glucose value from the outer body surface only. If some solution is non-invasive, then I can adopt in throughout the day, or maybe I can continuously use them. So that is a continuous glucose monitoring is possible. But that is the invasive and non-invasive. So invasive is with the two methodology which is currently available. Non-invasive is a proposed methodology which we can consider that is basically helpful in a smart healthcare mechanism. So for an invasive technology, when I take out the blood from a body and go into the laboratory, then the blood sample is being put inside the centrifugal pump. And inside this centrifugal pumps, what happens that your heavy particle of the blood will be settled down at the bottom, and at the top you will have some sort of liquid which looks like a water that we consider as a serum. And that sample of the serum is basically used to identify or to estimate the body blood glucose value. So that is a serum glucose measurement. Okay. Capillary glucose measurement is what we used to adapt at our home with the self-monitoring device. So over there, what you used to do, you need to take out the blood of your body and you lay down the sample onto a particular strip, and through that strip you can able to identify the body blood glucose value. So I'm not discussing in detail about the experimental, but the particular wavelength we have identified on which we can actually identify the glucose molecule detection. Okay, so that basically we have done the experiment, and through which judicially we have identified at 940 and 1200 nanometer. These two wavelengths are the important wavelength where the glucose particle can be identified. Apart from that, whenever a light, because ultimately if you want to adopt a non-invasive solution, then most of the time it is basically a light base, okay, where you use some sort of light source or photon to identify the disease. So here also in a non-invasive manner, what happens that light is being incident onto a fingertip. Now blood is flowing inside the finger, so that blood cell is having your body glucose value. So through when a light is being incident onto that particular blood sample, then either that light will be absorbed by the sample or it could be reflected. Okay, so that both the scenario for both the sensor 940 and 1300 that we have considered, and through which we come up with the first solution, which we consider as a iGlu 1.0. iGlu 1.0 is an intelligent glucometer version 1. Why we consider it as intelligent? Because it helps us to measure the body blood glucose value negatively. Apart from that, means here we are calibrating our sensor reading, okay, with the FDA approved device. So like AccuCheck, okay, whatever the FDA approved device that we use as a self monitoring purpose, that is a capillary glucose value. Okay, so those devices we have used for the calibration purpose, and then through a machine learning model we have predicted the glucose value. Finally, we have judged the error analysis by having a measurement of RMSE, your average error, or this parameter we have identified. This is same we discussed. So ultimately, we use a 3-channel data. Okay. So, yes.
Sorry to interrupt, sir, but are you changing the slide because it is showing? It is not showing. Like it is on the same slide.
On the 10th slide.
No, on 4th only.
It is like that. Let me check it again. Maybe I can share now entire screen.
Yes, sir. Entire screen will work.
Okay. Now, is it visible?
Yes, sir. Now it is visible.
Okay. So basically, self-monitoring devices are there, which actually help us to measure the body blood glucose value. Okay. Now we are proposing a glucometer, which we consider as an intelligent glucometer that we use as a term that we use as a iGlu. Okay. So here in the iGlu, we consider it is a smart healthcare solution where the data is being captured, the glucose value is being calculated, and that is being stored at the cloud. Okay. So this is the basically 3-channel data that we have observed it. Then we have upgraded that version to a iGlu 2.0. The only difference is here we are calibrating against the laboratory value. Okay, so in a iGlu 1.0 we have used the capillary glucose, that is a self-monitoring device for the calibration. Here we have used the laboratory value, and through which we are measuring the body blood glucose value. So that is a serum glucose. So for our testing purpose, we have used the different category people: pre-diabetic, diabetic, healthy, and total. Okay, just to showcase the demo, I am running one particular video. I hope video is running. Is it, sir?
Yes, sir. Yes, sir. Video is running.
Okay. I am inserting the finger. So you just observe that the device will looks like a pulse oximeter. You insert the finger inside the device. Then data is being captured out of the device. Then sensor will give some values. Okay. So this is the sensor value. Now this sensor value plugging into the machine learning model. So this is a machine learning model. Now if you just observe it, that from this machine learning model, 3 models are there. Okay. One is a random forest, another is a decision tree, and another is a Gaussian. So out of these 3, the 2 are showing that the estimated value is 87. So we consider that the predicted value from our device is a 87. Now, what is the actual value of that particular patient? So for that, we are comparing with the self-monitoring device. So at the same time, we take out the blood from the patient. Okay. So now what we are doing it, we take out the blood from the patient, and then through which we are measuring it. So it is 93. So this is with the AccuCheck. Now similar way we are measuring it with the another device, which is a Dr. Trust. To the Dr. Trust, it is 90. You just observe that the device which we use in a daily purpose, that self-monitoring device, is giving a reading 90, 93, and our prediction is 87. So such experiment we have done on a 350 patient, and with this we are getting around 90% of accuracy. Okay. Now, in order to validate the result, there is a Clark error grid analysis, which is a benchmark for a such device. Here you just observe that there is a x-axis, there is a y-axis. At the x-axis, the reference blood glucose value is measured, and on the y-axis, you have a estimated blood glucose value. Now, if your estimated and a reference glucose value is matches, then you will get some sort of linear relationship, and that linear relationship is basically residing in zone A. Okay, so whenever the reading is residing in zone A, then we consider that that is a clinically accurate device. Similarly, if reading is lying in zone B and C, then that is you require some sort of correction in your device. While D and E is an erroneous performance where you need to simply throw away that this device is no more can be used for a clinical purpose. Now, whatever the data that we have collected for a 350 patient, so out of 350, the 330 patient data is residing in zone A. So that itself suggests that our device is accurate. And remaining 20 in zone B and C. Okay, so that signifies that our device is accurate enough to be useful for the clinical purpose. So this is the error comparison. Okay, so we have measured the performance in terms of the different performance parameter. That is a mean absolute difference, average error, your R square value, where our algorithm or our proposed device is outperforming all the methodology. Apart from that, we are also, when we talk about the smart healthcare, then we are also providing some sort of remedial solution for a particular disease. Okay, so that we have adopted in our iGlue as well. So for that, we have developed the artificial pancreas. Okay, so artificial pancreas is one kind of mathematical model which actually allows us to predict the insulin secretion inside the body. Okay, so through in a type 1 diabetes patient, they used to take the insulin inside the body. So, okay, they used to take one prescribed volume of the injection. So that quantity they used to consume every day. Okay, but that could be a dangerous. Okay, so if your glucose value is already low, and if you are injecting the glucose insulin inside the body, then the value will keep on lowering, and if it can lead to a hypoglycemia state. So that hypoglycemia state is considered to be a very dangerous. Okay, so that's why that whatever the current solution is there, that is not actually a practical solution which could be adapted. So the good way is that maybe you can aware about, or you can have a knowledge about your current blood glucose value, and according to that you decide that what is the exact amount of the insulin you need to inject inside the body. So that problem we have solved it. Okay, so that is a basically artificial pancreas system, APS system. We have proposed it with the IOMT framework. Now, second case study, there is a upper limb prosthetic control. Okay, so there is the second application that we are going to discuss. Now, amputees, you will find out possibly means in a very rare. Okay, but those community are really suffering. Okay, where either they have some permanent disease, because of that they have lost any limb part. And if you consider the upper limb amputee, okay, so that is a significant damage for their daily life. Okay, because hand we consider as an important organ of your body, and you just consider that if we don't have a hand, then how we will perform our daily task. Okay, so another case study where we have developed a smart healthcare solution, where we have developed the robotic arm. Okay, so those people who don't have a hand, okay, then we can have a robotic arm, and that robotic arm will perform the activity like a natural hand. Okay, now good thing is that all our body activity is basically governed by a mind. Okay, your brain. So if your arm is not there, but your brain is sending the signal to perform their activity. Now, what is the idea over here? You need to just try to understand the intention of the brain. Okay, the which activity brains want to perform. Okay, so that activity you need to recognize, so that pattern you need to recognize, and then you need to supply the command to your robotic arm to perform that activity. Okay, so that solution we have developed over here. So that is you just consider that your left hand over here is a robotic arm. Okay, now brain is sending the signal. Now at your arm you are capturing those signal, and then you are supplying the command to perform that activity to a robotic arm structure. Now, for this, we have used the EMG. Now, what is EMG? EMG is the electromyogram. So that is whenever you observe the potential at your muscles of your body part. Okay. So if I don't have a hand, but possibly I have a muscles. So I capture a brain intention at the muscles. I decode that particular pattern and then I supply that to a robotic arm. So that is a solution that we have done it over here. So ultimately, the EMG signal where I extract the feature, then I will identify the particular activity and I classify them. This is the way that you can capture the EMG signal. So you can simply attach the electrodes at your forearm and through a forearm you can capture the signal. So surface EMG is the one way through which you can do it, and another is a intramuscular EMG. So intramuscular EMG is an invasive technique, okay, where you need to pinch inside your muscles and you take out the signal out of it. But that will create a trauma, okay. So people may not be able to use them for a longer duration. So surface EMG is the one of the way where non-invasively you just stitch the electrodes onto a body part and then you can able to capture the signal. So how the EMG signal generation is possible and how you can capture it? So ultimately brain, that is your cortex. The cortex will send the signal to perform one particular activity. That signal will be passed through a spinal cord, and through a spinal cord, it will reach to your motor neuron. Okay, so this motor neuron is being attached to your myofiber. Okay, so this actually we consider as a muscles. So this muscles is being connected to a motor neuron, and at this connection point, you have an action potential which is being generated, and that we are interested to capture through the EMG. So this action potential is nothing but my EMG signal. Okay. Now, the good thing is when I perform a different activity, then my different muscles are being involved and the potential which is being associated, those muscles are different. It is something like that when I pick up this particular mobile phone, then the different muscles are being recruited to perform this activity and the potential which is being generated is also different. Similarly, if I pick up this particular bottle, then also the different muscles are being recruited. Okay. And ultimately, those muscles are being generating a different potential to lift the force that is applicable to hold this object. Okay. So if I pick up the pen, then possibly the force which is being generated by a muscle is a different than to pick up this particular bottle. Okay. So that we need to identify using the EMG. So this is the way that muscles where you apply the surface electrodes, then you have some sort of signal in the conditioning block where you do a pre-processing, then there is a ML model, and then you have a robotic arm. So just showcase this particular solution. I am running a particular video. I hope this video is visible.
Yes, sir. Video is visible.
Okay. So here, this is me. I consider myself as a subject over here. So here I will show the demonstration of the EMG based prostatic control. So you just observe that at the forearm, I have placed some electrodes. Okay. So that is to capture the EMG signal. So EMG signal is being captured and that captured signal is being acquired by acquisition module. Okay. So that is the electrode. Through the electrode, whatever the signal is being captured, that is a red color module. That is the EMG acquisition module. Okay. So those get more that actually help us to identify a particular pattern. So brain has sent this particular signal signifies particular activity. So that activity is identified. According to that activity, the command is being generated, and that command is sent to the robotic arm. So if you just observe it, here there is a robotic arm. Robotic arm is having a white color. Okay. And that activity is being performed by a robotic arm. So what you need to observe it over here, you need to observe my hand and you need to observe the robotic arm. Whatever I am doing with my hand, the robotic arm will perform the same activity. So here I have demonstrated a three activity. First is a hand open, hand close is a second, third is a grasping of the bottle. Okay. So these three activity you will observe it over here. You just observe my hand. I'm opening my hand. So hand is open. I'm closing my hand. So I'm opening my hand again. So if you just observe that, I'm just molding my fingers. Similar way, the robotic arm has also having some sort of molding of the fingers. So anything in front of that particular finger, then it will hold it. Okay. So this is the basically the upper limb prosthetic control solution that we have developed. So nearer to us, there is a Bhagwan Mahavir Viklang Kendra. Okay, that is the biggest NGO where there are so many upper limb amputees are there. So we have supplied the solution over there and they are using it successfully. Okay. Now let's talk about the next problem, which is a depression. Depression is also one of the prominent problem. Okay, that happens inside many individuals. So basically that is being popped up right now in the students as well. Okay. When we talk about the total numbers of the depression, then India is the leading contributor towards the depression. And depression occurs inside the woman more frequently than a man. Okay. So what is the population globally of the depression? So currently 300 million people around the world are suffering from the depression. Okay. And in India, around 50% of the people are suffering from a depression. So in order to identify the depression, there are currently some of the solutions which are available. There is a Apple Watch. Okay, that Apple Watch is basically recognize your mood. That what is your mood, and from that they are actually identifying the depression. Another solution is where three sensors are being attached to your body. One is a temperature sensor to just measure the temperature of the body. Another is a humidity sensor to just observe the sweat analysis of your body. And third is your accelerometer, where you just observe your physical activity. Okay, this three sensor data is being fusion and then applied to a ML algorithm. And from that, you can derive that whether a person is a depressed or not depressed. Or if it is a depressed, then what is the stress level that a person is possessing right now. So that is the solution which is being there. Okay. So there are various ways through which you can observe the depression, but we consider that EEG is the best way through which the depression can be identified. So EEG is a signal where you capture the signal at your brain. So if you want to observe the brain activity, then you need to observe the EEG. Okay. So EEG could be of a different range. Okay. So we have also developed the solution of with the machine learning model. Okay, where we can identify the depression people. So we have used the LSTM and CNN model through which we are identifying the depressed or non-depressed case, that binary classification problem, with 100% accuracy. Now we will be discussing about the some of the emerging application which currently available, which we can adapt in a personalized healthcare management. And currently research is going on where you can focus it. So those who are basically interested to go for a research, then possibly the few application which I am explaining over here, that is for you. For an intelligent diet control. Okay, so it is very important. Okay, if you are a diabetic patient, then we talk about that you need to go for a diet control. What you need to eat and what you do not have to, that you need to take care. Okay, so for that you should understand that what you are consuming right now. Okay, what is the calorie amount that you are consuming right now, whether it is suitable for your body or not. Okay, so currently there are few apps are there. Okay, what they used to do that whenever you are taking a particular meal, then you can simply take a picture of that particular meal from your mobile phone. Now the image classification will be done, and through which they will identify that what is the food item that you are currently consuming. Most of the food item, they are having some fixed calorie count, and that data set is also available, and through which you can identify that what is the exact amount of the calorie you are going to consume by adapting such solution. Now most of the time your packed food item contains your calorie count. Okay, but your vegetable fruits for you don't know. Even when I am taking a one particular thali, at that time also I am not aware about that what is the exact amount of the calorie count of this particular food item. So that I can do it with, or if I can have some mechanism through which I can identify. Now, few applications are there, but there are problem with that, and specifically with the Indian context. Okay, because in India, we talk about the North India. That is in India, the South and there is a different North India. So very diverse we have. Okay, and with that, there is a diverse nature of the food items we have. So image classification is one of the problem that you need to correctly identify the image, but according to that calorie count. So maybe whatever the dal that is being served at the North India, the calorie count is different than the whatever the dal which is being served at the South India. Okay, so that is still a open problem which people are trying to solve, but still nothing for the Indian perspective. The solution is being developed. Then telemedicine. So telemedicine is one of the upcoming, you can consider the field where means doctor will try to meet the patient with the means remote place, okay, where they can provide some sort of teleprescription. Then they will provide some sort of medication to a patient. They will consume it, and then again they will take some sort of preventive action and again share the data with the doctor. Doctor will observe the effect of that medicine to a patient. They can provide. Now they can provide with play okay the outcome during the testing phase. Okay. Now if I want to solve the problem, over here we play, and what is the personalized solution? Okay, because that solution. Well, yes, anybody can tell me whether yes. Yes. Am I audible?
Yes, sir, you are audible.
Yes.
Sir, your voice was not clear, but
Anybody
you are
can,
audible.
okay, okay.
Yes, sir. Now it is clear.
Okay, I will try to speak little bit of louder. Okay. Is
No,
important is we should get. Sorry? Huh?
No, sir, nothing. Nothing, sir.
Okay. Okay. So personalized solution development is very much important. Okay. So most of the time we are taking a generalized solution. What I mean by generalized solution, doctor will give some sort of prescription for a, let's say, for a similar symptoms to me and for to other patient as well. Okay, but it could be a case that other patient is able to means cure or take means that disease is being preventive for that other patient, but for me it is not working. Okay, because each and individual body structure is different. Okay, so for X patient, if some medicine is working, then it is not necessary that for a Y patient also it will work. But the AI will help us in this particular case. Okay, because doctors actually looks for a symptoms and they provide the medicine to a symptoms. Now whether that symptoms is for the X patient or a Y patient, but if we use AI, then AI can have a capability to provide the personalized solution. Now what we want to have is that we want to train a system with our personalized data. Okay, so whatever the data which is being generated from my body, those data I will use for the training purpose. The model is being trained with that, and then we will uh, test with those particular data. So that means whatever the outcome would be very good for that particular patient through which we have captured the data. It may not be work for the Y, but if the data is being captured from the X and train the model with the X data, then it will be providing a very good solution for that particular expression. So that could be possible. Okay, so that could be done. Okay, another is a robotic. Now, robotic will play a very crucial role, and currently also it is playing a very crucial role. Okay, so during the COVID time also the robotic technology was used to for the food delivery, maybe to collect the samples from the patient. Okay, now this technology is going to be evolved in upcoming years. Okay, so more and more robotic based solution. Now people are talking about robotic surgery. Okay, so that could be a reality. Okay, that in a your normal practice as well. Okay, so robotic will play a very crucial role to provide the solution. Now similarly, industry 4.0. So industry 4.0 will also allow us to identify the exact demand, and according to that I can provide the supply. So through a smart manufacturing, I can predict that these particular resources may require at that particular place, and according to that I will generate those, I will manufacture them, I will try to transport them with some sort of smart way so that it can reach early. Okay, so I will adopt the smart production, so that means I can provide the early delivery to the solution at the proper time. So this industry 4.0 could be playing a vital role to adopting such kind of solution in a healthcare domain. Okay, the trusted food supply chain management, that is very important. Okay, because after the COVID we used to have a word like a immunity. Okay, and you just observed that currently that most of the product is basically sold because of the immunity. Okay, now whether that particular food product is actually boosting your immunity or not, because if it is not in a proper format or not in a proper form, then it could have an adverse effect, that it could lose your immunity. Okay, but as a user, how I can identify that whether this particular food product is of a good quality to consume at this particular time or not. Okay, so for that we can have a trusted food supply chain management. Okay, so where I can simply scan that particular product and I will get the information. What kind of information I expected? When this particular product is grown, when it is being transported, when it is available for the retail shop, and while I am consuming that, what is the time duration and what is the actual quality of that particular food product. So usually when I consider a fruits, then fruit is having a specific lifespan. Okay, and within that lifespan only you need to actually consume that fruit item. Now, if you are exceeding them, then it could have a reverse impact on your body. Okay, so basically, trusted food supply chain management will help us to identify the quality. Another important aspect is digital twin. Now, digital twin is one of the very popular term, and which actually will transform the healthcare sector as well. So, what is the digital twin? Digital twin is, you can consider, replication model of your physical system. Okay, because in a healthcare domain we need to perform the clinical trial. Okay, if some vaccination is developed or some drug is being discovered, so there has to be conducted the trial and you need to observe the impact on a human health. Okay, so we can create the virtual digital twin. Okay, over there we can validate our experiment, and through which the experiment and conducted clinical trial will be conducted, and I can easily get the approval of that particular drug model. Now, digital twin could be useful to have a personalized medicine. It could be helpful for a disease prediction and the prevention. It could allow us to have a optimized treatment for an individual. It would also allow us to have a remote monitoring. Now, digital twin of the heart, which is very important topic and which is upcoming topic. Okay, so currently the great research is going on to create a digital twin copy of the heart. And heart we consider is a very important organ of our body. Okay, so now if we can replicate a performance of a natural heart with the artificial heart, then it would be game changer. And at least with the heart attack or heart related disease, nobody will die. Okay, so currently the research is going on. Can I have a artificial heart which will mimic the performance of our natural heart. So digital twin for the heart is a current research where people are working. Now challenges, possibly in the last 5-10 minutes, I will talk about the challenges which are lying ahead for a personalized health management. Okay, so the challenge is your privacy and security. Okay, see, by adopting a variable technology or maybe some sort of smart healthcare component, I am generating the data, but that data is a very personalized data. Okay, and to preserve, and the thing is that whatever the data is being generated, that access should be allowed to a only limited set of people. Okay, so for that, the privacy is okay. Something like if I have been affected, or let's say that I'm having a cancer, but that I do not want to announce among the people. So that is a very private information that should be accessible to the only limited set of people only. Okay, so that data privacy should be preserved very well. Another important aspect is the security. How secure your data is. See, from this variable sensor, you are capturing the data. The data is being stored at the cloud, but are those data secure enough? Because whatever the data which is being stored, on which you are applying AI ML algorithm, you are deriving some decision, you are taking a decision regarding the treatment of the particular patient. But if that data is not intact and it is being tampered by somebody, then the decision whatever you have taken is a wrong one, or maybe whatever the treatment that you have started, that will be a wrong one. So privacy and security is very important. Apart from that, the hardware security of the device. Okay, so whatever the device is which is being deployed inside this particular system, they should be secure enough. There should be access control mechanism. Okay, that those device is accessed by a limited set of people. Okay, it is something like that. I am using a pacemaker to actually having a regular pumping of my heartbeat. But if some third person is getting a control of that pacemaker and then it is changing its setting, so it could lead to a loss of a life of a particular patient. Okay, so whatever the device which is being used over here, that hardware security of the device is very much important. Okay, data integrity is also one of the important aspect. Whatever the data which is being generated by that device, it could be stored in a local memory of the device or it could be stored in the cloud. So that data should be also preserved in a very well manner. As I said, that access control and authentication, to whom I need to allow to access this data and who should be able to modify the data. Okay, so that is to be managed very cleverly for smart healthcare. Now, power management, this is very much important. Okay, because I want to capture the data from my body throughout the day. Okay, so it is something like that, that when I am sleeping, but my body is working. So means that smart healthcare solution should allow to capture those data. But those variable technology are battery operated. Okay, because they are basically running on a battery. Okay, so ultimately the power management is a critical issue. So I want to roam around. At the same time, I want to capture the as many parameter as I can from my body. So for that, the battery life is playing a very crucial role. Okay, so you need to think about some better solution where you have some sort of energy saving mode, or you have some sort of the way through which you can minimize the power requirement during the inactive hours, and during the active hours where your body is working in frequent way. Okay, so at that time the means whatever the parameter which is being captured is a full, and at some time only limited parameter could be captured, so that could help us to get the battery management. Another important aspect is interoperability. Now what do you mean by interoperability? Interoperability is very important aspect for the internet of medical thing. See, we have so many things which are there in our IoT network. When I consider the IoT, it is a heterogeneous network. Okay, so there are so many devices which are being connected with each other. They are sharing the information through a connected health network. Okay, but they should also allow to talk with each other. Okay, so it is something like that. I have a 10 device, but that 10 device is basically of a 10 different manufacturer. But what is the current scenario that if I want to have some sort of interaction, then the device should be of a same company. It is something like that if I have a TV from a Samsung, then I should purchase the remote of the Samsung only. Through a Philips remote, I cannot control the Samsung device. But when I talk about the healthcare domain, in a healthcare domain, you can have so many sensors, you can have so many devices. Okay, and it could be a case that I want to send a command from a Samsung device to a Philips device, and it has to perform that particular task. But currently, the protocol is there that is not being allowed. Okay, so that is actually considered to be breaching the protocol of the individuality of the company. But as a user, I want a seamless connection among the device. Okay, so that could be possible where the interoperability issue is being resolved. So it is something like that I want to control a X device with the Y protocol. Okay, so for that, all this manufacturer has to come in a common platform, and they need to decide that within this particular protocol the information exchange among the different device is possible. Okay, because as a user I should have a flexibility to decide that which one is suitable for me. There could be a multiple factor for that price is there, maybe the I am more interested in a possibly a fancy design, the form factor. So all these are parameter where user should have a clear cut choice. Okay, that which one it has to use it. Now, finally, I want to conclude that ICT technology and Internet of Medical Things, that is the IoT technology, will play a very crucial role to adapt the smart healthcare application. Different kind of AI algorithm and intelligent mechanism will allow us to take a better decision in a healthcare domain, and that actually help us to transform the traditional healthcare system to a healthcare system, smart healthcare system. When we want to think about adopting a smart healthcare mechanism, then definitely there are some challenges that we discussed, that privacy, security, power management, interoperability, hardware security. So those has to be addressed first so that the people get the confidence to use them. So currently the lots of research is going on in this particular field. We can see that possibly in the next 2-3 years most of the challenges will be resolved, and we would be using such kind of solution in our daily life. So with this I am ending up our session, and I am open for your question answer. Yes, questions if you have, I will be more than happy to answer those.
So if anyone is having any queries, they can put up in chat box. I will convey the message.
Okay, they can put it in a chat box, or maybe if they are allowed, then they can speak also.
Yes, they can put up in chat box. We will allow them to unmute themselves.
Okay. Yes, any question? If you have any specific question, then I would be more than happy to answer those. Oh. Okay. Maybe you can raise your hand also so that. Okay. So it seems that as of now there is no question. Okay. Good.
Yes, sir.
Okay. So means if you have any question later on also, then possibly I will share the slides with them. And if you have any question, then you can contact me at any time. Okay, you can find out my information from MNIT website. Okay, and I would be more than happy to answer your queries. Okay, so thank you all of you for patiently listening to me. Okay, And thanks you or thanks for the organizer to allowing me to interact with the people.
And sir, on behalf of FDP organizing committee, like we would like to heartfully thank you for contributing to our FDP, and your information on IoT in healthcare was like very good and very informative. We look forward getting more information from you in further FDPs. Thank you, sir, for contributing.
Thank you, thank you, thank you. Have a nice day. Have a nice day. Thank you, all of you.
So to the participants, our valedictory will start from 4 p.m.